Before you go online and spend $200 on a new mass airflow sensor because some forum stranger told you to, stop right there. I am going to save you money today. We are going to do some real detective work using a tool you probably already have in your garage, a digital multimeter. Testing a mass airflow sensor, or MAF, is actually one of the most satisfying diagnostics you can do because it makes you feel like a scientist, and it gives you a definitive answer. No more guessing. Now, grab your multimeter. You do not need $1,000 fluke meter for this. A cheap $20 unit from the hardware store works perfectly fine. Set the dial to DC volts, usually represented by a V with a straight line over it. The first thing we need to do is get access to the sensor's wiring. You will see a connector plugging into the sensor on your air intake tube. Do not unplug it. We need to test the sensor while it is actually working, which means the car needs to be on and everything connected. This is where a technique called back probing comes in. You need some T-pins, which you can steal from a sewing kit or actual back probe needles. Do not, and I repeat, do not pierce the rubber insulation of the wires with your multimeter probes. If you poke holes in the wire insulation, moisture will get in, the copper will corrode, and you will have a wiring nightmare a year from now. Instead, gently slide your T-pin into the back of the connector where the wire goes in, right between the rubber seal and the plastic housing until it touches the metal terminal inside. Now, most mass airflow sensors have 3, 4, or 5 wires. We need to identify them. Usually you have a power wire, a ground wire, and a signal wire. If you have a 5-wire sensor, the other 2 are for the intake air temperature sensor, which is built in. Turn your ignition key to the on position, but do not start the engine. Take your black multimeter probe and touch it to the negative battery terminal. Take your red probe and touch your T-pins one by one. One of them should give you 12 volts, or close to battery voltage. That is your power feed. If you do not have 12 volts there, check your fuses because the sensor is not getting power. Next, we need to find the ground. Switch your multimeter to the continuity setting, the one that beeps when you touch the probes together. Touch the black probe to the battery negative and the red probe to the remaining wires. The one that makes the meter beep is your ground. Now, by process of elimination, the remaining wire is your signal wire. This is the one we care about. This is the wire that talks to the computer. Switch your meter back to DC volts. Connect the black probe to the battery negative and the red probe to the T-pin on that signal wire. Start the engine. At idle, you should see a steady voltage. For most cars, like Toyotas, Fords, or Nissans, this will be somewhere between 0.5 and 1.5 volts. It should be rock steady. If the numbers are jumping all over the place while the car is just sitting there idling, your sensor is likely dirty or failing. Now, for the fun part. Reach over and manually operate the throttle lever on the engine, or have a friend step on the gas pedal. As the engine revs up and sucks in more air, that voltage should smoothly rise. It should go from 1 volt at idle to maybe 2.5 or 3 volts at 3000 RPM, and all the way up to 4 or nearly 5 volts at redline. The key word here is smooth. It should look like an airplane taking off, a nice linear climb. If you see the voltage go 1, then 1.5, then drop to 0, then jump to 3, you have what we call a dead spot. That means the potentiometer or the electronics inside are worn out. That is a bad sensor. Now, I have to mention a curveball. Some cars, specifically General Motors vehicles and some European models, use a frequency-based mass airflow sensor. If you hook up your voltmeter and you see a constant 5 volts or 2.5 volts that does not change when you rev the engine, do not panic. Switch your multimeter to the hertz or frequency setting, usually labeled HZ. Now do the rev test again. You should see the frequency number go up as you rev the engine. It might idle at 2000 hertz and go up to 8000 hertz. The logic is the same. Air goes up, number goes up. Finally, there's the tap test. With the engine idling and your meter hooked up to the signal wire, take the handle of a screwdriver and lightly tap the plastic housing of the sensor. I said lightly, do not smash it. If the engine stumbles or the voltage reading spikes dramatically just because you tapped it, you have a loose internal connection or a broken solder joint inside the sensor. That is a fail. By following these steps, you're not just hoping the part fixes it, you're proving it. You become the master of your machine, and that's what DIY is all about.